So the 2025 dynamic mechanisms question. So the first part is a cam based on a pull along toy frog. Now, first things first with these is to draw the displacement diagram. Alright, so we've basically just been given a set of instructions for the displacement diagram. We have a UAR, a UV, and a simple harmonic motion to put into that diagram, and then we can draw the cam afterwards. Okay, so that's just it's not one of the ones where they're mixed or anything like that. It's just straight displacement diagram first, cam afterwards. We're not working between the two or working backwards or anything like that, right? So I've basically done out my sections here for my displacement diagram. I'll talk to you about the height of the diagram in a second. Alright, just one thing to note, they've asked for 12mm spacings between these. Alright, a lot of the time we use 10, sometimes they ask for 15, but in this case it's 12, right? It's the last sentence there in the question. Use a distance of 12mm for each 30-degree interval in your displacement diagram. So that's fine. Okay, and they go from 0 degrees, then you've got 30, 60, 90, 120, so they go up in 30s right until you get back around to 0, or you can call it 360 if you like, it makes no difference. Now, the height of my diagram, okay, so what you must do is add all the total rise together, alright? So the first step of our diagram, you can see from 0 to 120 degrees, it's a rise of 36, right? So if I just write down 36 millimeters, then the next step is a rise of 24 millimeters, alright? So at the moment we are at 60, and then the last one is a fall of 60 as well, so we're back down to 0, right? So the total height that this thing is going to rise up is 60 millimeters. So I'm going to come along, mark a height of 60, and just fire that across there. You can just start drawing these in here then. So draw each one of your 30-degree intervals straight up, and that completes our box then for our diagram. No. Alright, so pause the video there if you're not ready to move on. So, first things first, right? We always start here at 0, and I'm going to be going, so it's a rise of 36 millimeter, right? So it's going to, this first section is going to have a height of 36. So I'm just going to mark height of 36, and it's going to go over as far as 120 degrees, right? So it's going to finish here. So it has risen 36, but it's going over 120 degrees. Now, inside this section here, we are going to have a uniform acceleration and retardation, right? So a UAR, right? And I'll go through each one of them individually here in a second. I'm just going to move on and do the next one here as well while I'm at it, right? So I'm going to rise another 24, right? So that's going to be to the top of the grid, and it's going to be to 180 degrees, so it's going to go to here, right? Now that's a UV, so there's nothing kind of complicated with a UV. UV and dwell are the easiest to do, they're just straight lines. Okay, so I could just do that one there. And then the last one is from 180 degrees back down to 0. Right, now fall of 60, so it's going to go down to this corner, and that's going to be a simple harmonic motion, right? So there's a curve in that one as well. Right, so how to do a UAR, right? So essentially, a UAR, right, if I was to put it into this box here, right, so like this one we're starting here, excuse the dodgy line at the top there, right, we're starting here at the bottom, we're going up to the top here. What you want to do, we've got the length of it here and the height of it, right, so the height and the length is going across. And I want to divide the length into 6 equal sections, so you have 6 sections there, and you will draw those going straight up. Now, the middle one of these lines, so here's the third one, alright, that's the height. I also want to divide that into 6. So, I'm just going to do that. So that's into 6 as well. And what you do is you connect the bottom corner here to the first 3, like so, and the top corner to the top 3, like that. So you basically end up creating that. It's actually 2 parabolic curves. So it's parabola in 2 directions, and you end up with your curve then that goes like that. Okay, so basically like the first one of these diagonal lines crosses the first one, or the second diagonal line crosses the second one. The third is actually just the very center of that, and then the same at the top. You can obviously have this in reverse going down the way as well, alright, but in this case we're going up the way. Now, this is divided into 4 sections already, which is no good to us. Sometimes they actually have it, it's across 3 sections. We just divide each box in half again, we get our 6. But in this case, they haven't actually done that. Alright. Now, so what we need to do is divide from 0 to 120 into 6 parts. Now, it's 48 millimeters in length. So if you divide 48 by 6, you get 8. So basically we're going to use 8 millimeter spacings. Right, now I'm going to use a colouring pencil just to separate these. So we'll go 8, then 16, 24 is going to be the middle one. I'm going to put 8 again, 8, and if I do that's my last one. Right, so there's a lot of lines inside here. So each one of these goes up. So I'm only working with these green ones here now at the moment. I'm ignoring the ones that are the lines that are there for 60, 30 and 90. Sorry, the 61 will be the middle one. Right, so it's just those ones I'm working with at the moment. So ignore the one that's on 30 and 90 if you can try and blank those out completely. Now, so as I said, that's this divided, the length divided into 6, and you go to the middle one, which is the one that's on 60, and divide the height of that into 6 as well. Now that's 36, so that divided by 6 is gaps of 6 millimeters. So again, it's kind of convenient. So you can use 6 millimeter spacings for those. Alright, so that's those there. Now what I'm going to do, as I said, is connect the bottom corner to the first 3. And the top 3 to the top corner. You end up with that. Alright, so I'll actually just zoom into that section there for you. So my first point is where those two cross, my second point is where those cross, the middle, this one here, and then with my freehand arc then. Right, that's the UAR. The UAR is without question the hardest of all the possibilities that come up for displacement diagram of all 4. In order of difficulty, the easiest is dwell, then UV, then simple harmonic motion, and then the hardest being UAR. Right, now we must do a simple harmonic motion here at the end, so if you're not ready to move on to that, just pause the video and finish off your UAR, and then we can move on to the simple harmonic motion. But I'm going to drive on here now. So with a simple harmonic motion, what I want to do is put a semicircle at the end. So that will be the center there. Now you can do it in here as well. It doesn't actually matter whether it goes to the left or the right. It makes no difference. Semicircle here at the end, right? And it's going the full height. Because it's going from the top down to the bottom. For example, if this was meant to be a simple harmonic motion, it was only meant to go from here to here, then my semicircle would be from here to here, right? It would be smaller. But it's just because it's following the full distance. We take the semicircle and split that into 6. So just use your 60-30 for that. So, right. And the points of those, just bring them across, right? So we're starting here, I'm going to do is take this first point here, right to the first point here, so that one goes there, second one, third one, fourth one, the fifth one, and then we finish down here. Alright, that's your simple harmonic motion done then. So generally the simple harmonic motion isn't too bad. The UARs can actually be okay. It's just when they come into issues like it's only across 4 sections, it gets a bit messy and it's quite small in there as well. But they can be okay. But the simple harmonic motion in this case was simple enough. We were also lucky as well because it was already 6 sections going from 180 to 0. Okay, we could have had a situation where we had our UARs here as well, where it was only 4, and then we'd have to split that up into 6 as well, but we didn't have to do that in this case. Okay, so we were kind of lucky in that sense. Now, that's our displacement diagram done. Alright, it's just a case of moving on to the cam now. So, the hard work is done. Right. So I'll go off now and I'll draw the cam. Right, now just reading the question here, right? So to draw the displacement, okay, it's an inline knife edge follower. Okay, so that'll be important in a minute, and I'll explain what it means by knife edge in a moment. Usually what I do is whatever space I have left from the end here over to the edge of the page, I go to the middle of that and I just draw a vertical line down through it. Okay, then, alright, so it says here the nearest approach of the follower to the cam center is 40 millimeters. The nearest approach point is there. Alright, so the bottom of the diagram here. So what I'm going to do is I measure down 40 from there, right? And it can get a bit confusing because it says cam shaft diameter as well is 20 millimeters. And people kind of wonder, oh, do I measure down 40 or do I measure down 20? So the nearest approach of the cam to the cam center is 40, right? So the fact that it says cam center, it's the distance to that cam center, so I'm measuring down 40, and that gives me the middle of my cam. So I'm just going to put C for center there, right? What they mean by camshaft diameter, right, and you do actually have to draw this, otherwise you'll lose marks, is draw a diameter 20 circle here. That's that. Alright, that's your camshaft. Alright, so it's basically the bar at which the cam would rotate around on. You do have to draw that, you lose marks without it, but that's not essential to actually drawing the cam, right? The important thing is that you have the cam center in the right place. It's down 40, right? So that's your nearest approach distance. Now, I need to draw some lines that go at 60 degrees and 30 degrees through those, right? I'm going to use a red pen for those, right? I should just use your pencil. Now I know the pen isn't looking very red on the video here, like, but it's just the camera, unfortunately. Alright, now this here is 0. Alright, we have for each 30 degree interval of these. Alright, now it says that the cam rotates in an anti-clockwise direction, so the cam is rotating this way. Now, in the cam question, and it's only in a cam question, if it says anti-clockwise, then you label it clockwise. Right? It is the only time where you do that, okay? And it can be easily forgotten about. but it's just simple marks that you don't want to be losing. You don't lose a huge amount for it, but it's just, you know, don't make the mistake of just doing it that way. Just make a mental note of it in a CAM question. If it says label clockwise, or sorry, if it says it rotates clockwise, then you label anti-clockwise, and if it says you rotates anti-clockwise, you label it clockwise. Okay, so it's just the opposite, and it's only with this question. Now, next thing to do is bring our points. So I'm working, see with the line diagram here now, so this is our displacement diagram, this is the line of it. I want to bring the points where that diagram crosses, where 30, 60, 90, 120, all those points are. I want to bring them all over onto this 0 line, right? So where my line crosses the 30 line here, right? So there's my 30 line going up. The one we actually ignored earlier on. Where that crosses there is that point. I'm going to bring that over onto 0. So that's that one, right? Now I'm going to do these one at a time just to show you. And what I do is I brought that over to here. I put my compass on my cam center, and then I rotate that onto the 30 line. I get there. Okay, let's do that with the next one. So the 60 one, which is here. Okay, so again, here's my 60 line, there's my diagram. So bring that across. Now I'll rotate that onto 60. At that point, same again, I'm going to go up to where 90 is, just there. Rotate that. Right, you can see where I'm going here. Alright, now when I've got all these completed, because this is a knife edge follower, I can connect those freehand. Alright, you have questions where there are roller followers or flat followers, and you have to draw, if it's a roller follower, you have to draw a circle at each and draw the curve on the inside, or if it's a flat follower, you have to draw a line and then as well along the insides of those. But because this is a knife edge, you just connect the dots. Alright, it's just the easiest, there's less work involved. Alright, so I'm going to drive on here now, and I'm going to bring all my lines over. And if you're going to get lost, then it might be an idea to just do them one at a time. You know, each person is different, but I just bring them all over. It's just because I'm used to doing it that way. Right, now you will have situations where points are very close like that, and that's just kind of the way it is. You have to kind of just be careful if you are bringing them all over that you are working with the right one. Right, so 120 is this one, so just follow it very carefully. I'm just going to keep my eye on that. Open it up, swing it around, and I do suggest that you swing them around, make it easier for the examiner if you do make an error to see where you might have gone wrong. Whereas if you're just literally marking it, it can be just a bit more difficult for the examiner to find out where you made your mistake. Right, no, that's all of them. Alright, now I like to, actually before I do that, I'm going to draw in a follower. So another thing you will lose marks for. You don't draw one. Right, is draw some sort of representation of a knife edge follower. So I usually just do a V there at the end with a 60-degree set square, and I keep it, 8 or 10 millimeters wide. It doesn't have to. It has no specific dimensions. I just draw it in, and then I untape my sheet and draw my freehand curve, then connecting all of those. Okay, that should look something along those lines. Alright, so that's that finished. Alright, as I said, that was 2025 question C4, that was part A, the frog.